So now we're going to write structural and condensed formulas for each of the following organic compounds. A structural formula is pretty much very similar to a Lewis structure. It's just with organic molecules, remember, you're going to have these big long chains of carbon. And then the condensed is taking into account the arrangement of the carbons and the hydrogens in the formula. So it's a little bit different than the molecular formula. Remember that the most important thing is the ending of the name. So when you see, for example, ethane, the ANE is going to tell me that these are all single bonds. So what I'm going to do is I'm going to connect two carbons with all single bonds, so basically just one line, there's two carbons. Then remember, you fill in the extra bonds that are needed with hydrogen. So again, we're going to go back to our octet rule. Each carbon needs to have four bonds around it for a total of 8 valence electrons. So right now it only has 2 on each. There's 2 for this one and 2 for this one. So right now you're going to do 1 hydrogen, 2 hydrogens, 3. So when you add those 3 hydrogens, you're going to get 1, 2, 3, 4 bonds, 8 electrons, complete octet. So as you see, you add hydrogens to complete the octet around the carbons, and then what's going to happen automatically is 2 carbons and then 6 hydrogens. 1, 2, 3, 4, 5, 6. So there's my structure. Then when you do the condensed form, what you do is you pay attention to each carbon individually, and you kind of like give each carbon a formula. Think of it like that. You're giving each carbon a formula. So if you look at this carbon, there's 1 and 3 H's. So you would write CH3. And then around this one, again, there's 1 C and 3 H's, CH3. So you're giving each one kind of its own individual formula. It's showing you the order of the carbons and the hydrogens. So next we're going to look at ethene. The ENE tells me it's going to have 1 double bond. The double bond can technically go anywhere, but just for ease, let's put it on the middle. So I'm going to have 2 carbons connected with 1 double bond. So again, we fill in the hydrogens according to the octet rule. So right now this carbon has 1, 2, 3, 4. 2 bonds, 4 electrons, and this one has 1, 2, 3, 4. So what you got to do is add H's. Now they do go off in this structure because of that double bond. So if I add 2 H's there, you're going to have 1, 2, 3, 4 bonds around this, 8 electrons. Same thing to the other carbon. And again, I'm going to have 4 bonds with 8 electrons. Again, for the structural, you think of the carbons as individual. So the first one has CH2 and the second one has CH2. Okay, for this next one you have yne, Y-N-E. That means there's going to be 1 triple bond. So again, now I have 4 carbons. So what I'm going to do is I'm going to do 1, 2, 3, 4 C's, and I'm going to connect the middle one with a triple bond, and the rest just with single bonds. Again, I fill in the H's according to the octet rule. So this C right now only has 1 bond, 2 electrons. So it needs 1, 2, 3 hydrogens. This next one, now count, has 1, 2, 3, 4 bonds with 8 electrons around this carbon. It doesn't need any more hydrogens. It doesn't need any to fill in. Same with this one. 1, 2, 3, 4 bonds, 8 electrons. It doesn't need any more. We get to the last C. It only has 1 bond with 2, so it's going to need 3 hydrogens. And look what happens. It automatically goes to the formula. Now I have C 4 carbons, 1, 2, 3, 4, 5, 6 hydrogens. It's automatically going to do that. Again, think of the C as individuals, and you're writing the formula for each C. So the first one is CH3, then we have a C, another C, and then CH3. Okay, next we have propane. ANE tells me it's all single bonds this time. So I'm going to do 1, 2, 3 carbons all connected with single bonds. Then I need to fill in the octet rule. So I have 1 bond, 2 electrons. So I have 1, 2, 3, 4, 5, 6, 7, 8. 1 bond, 2 bonds, 3, 4. And the last one needs 3 hydrogens to complete it, and now they all have a complete octet. Again, for the structural, you're taking each carbon individually and you're writing a formula. So the first one is CH3, CH2, CH3. Okay, and this last one is going to be octene, E-N-E, double bond. Easiest just to put it in the middle. So I'm going to draw 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to double bond the middle, single bond the rest. Remember, you fill in the hydrogens. So now you're going to fill in the hydrogens to complete the octet. Remember, you need to complete octet. Everything needs 4. So I'm just going to start filling in hydrogens here. Now, when we get to this one, remember, it has 1, 2, 3 bonds attached, so it only needs 1 hydrogen to complete the octet. It doesn't really matter if you put it on the top or bottom. Same thing with the next one. Again, doesn't really matter top or bottom. When we get to this carbon, however, it has 1, 2 bonds, so now it needs 2 more again. Same with this carbon, and the last one again needs 3 to complete the octet. And then when you go to draw the condensed formula, again you're going to look at every carbon individually and you're going to give its formula. Now this one has 8, so it's going to be a little bit longer, but it's the same thing. So it's going to be CH3, CH2, CH2, CH, CH, CH2, CH2, CH3.